So now we're ready to turn our attention to topics related to concurrency and schedulers that are related to the Flux class. And we'll see that this is really why you use this technology, because you want things to be able to run asynchronously. So we're going to talk about some operators that are used to arrange to run other operators in designated threads and/or thread pools. And we're going to take a look at subscribe on and publish on, which are two operators defined in the Flux class, and then the scheduler's new parallel method, which is defined in a separate class, but used with Fluxes. And I'll talk about why it's done the way it's done. So first we'll talk about the subscribe on operator. And you'll see that this is used to run the various methods that are part of the Flow API, like subscribe, onSubscribe, request, and so on the specified scheduler that's given by the scheduler parameter. So the scheduler parameter indicates what thread to perform the operation on. And you can have a thread pool, so it could be a set of threads, not just one. OK, a couple of interesting things here. One of the things that you'll note is that the schedulers are treated separately from the Fluxes. So scheduler is passed as a parameter to a Flux. And we'll talk about why that is in a second, but it's interesting to think about that. And the reason why it's done that way is because there's also other classes like parallel fluxes or monos that also can work with thread pools or special threads. And so by factoring out the scheduler to be in the subscribe on methods, rather than baking it into the Flux itself, it allows us to have one scheduler collection of schedulers, one scheduler coterie, and be able to reuse them for the different reactive types that are in Project Reactor. So that's why we factor that out into its separate thing. This subscribe on method returns the Flux that's now requesting asynchronous processing on the schedule that was provided as a parameter. The semantics of subscribe on are a little bit weird, right? It's like having a square apple or a square orange. It's probably still tasty, but it just doesn't look like what you might expect. And the way it works is you can place this operator in a chain, and sort of no matter where you put it, it affects the whole chain. So if you put it in a chain, then all the methods that are called in that chain, all the on next, on error, on complete signals that propagate through that chain, are going to end up running on the designated scheduler. So in this particular example, which we'll talk about more in detail when we get to the case study, we make ourselves a new publisher, which is going to be a parallel scheduler, and we're going to give it a count of 1, just says give me a thread pool with 1 thread in it. And then we're going to say subscribe on. And what's interesting is everything in this Flux, including the range method that occurs before subscribe on, will now run in this background thread. Now what's particularly interesting is you can put subscribe on here, or you can put subscribe on here, or anywhere in between, and it has the same effect. It just says this thing is all going to run in that scheduler context. That to me is a little weird. It took me a while to get my head around that, but that's just the way it works. However, this is the caveat to this. If a publish on operator, which we're about to talk about, appears later in the chain, so let's say we have subscribe on here, and then ... publish on somewhere, then the publish on operator will be the one that takes over the thread context where the rest of the operators in the chain will execute. And to make things even more flexible and somewhat complicated, you can have multiple calls to publish on in a Flux. And we'll talk about that. I'll show you some examples. It's quite interesting. RxJava has a subscribe on operator in its observable that works the same way that it works with Project Reactor's Flux. And I should probably say that there really is no equivalent to this in Java streams other than saying, .parallel stream or whatever. So with streams, when you create something, you typically say that what it is. And of course, in parallel streams, you can use the sequential and parallel operators anywhere in the stream, but it doesn't have quite the same semantics that the way things work with subscribe on. To some extent, I like the parallel streams model a little better because it's a little bit more obvious what's going on, whereas this can be a little complicated at times. So that's subscribe on. And subscribe on is most commonly used to implement something called the flat map concurrency idiom, which we'll talk about later. Let's talk about publish on. So publish on is an operator that, again, like subscribe on, will run all the various signals like on next, on complete, and on error in the supplied or the given scheduler parameter. And once again, that indicates what we want. Again, we factor out schedulers so we can plug and play that with monos and parallel fluxes and fluxes to get maximal reuse. And like subscribe on, publish on returns a flux that is now going to be enabled to process things asynchronously using the given scheduler context. Unlike subscribe on, which is a little bit complicated, the semantics of publish on are really quite straightforward. So what it does is it will influence the threading context, or it'll designate the threading context where the rest of the operators on the chain below it execute. So here, if we do it like this, we can have create async flux sync, which could be running in one thread. Then we could go ahead and do publish on, which would go ahead and run the rest of the chain in a different context, and that gives you more flexibility. And what's interesting here, if you're so inclined, you can put other calls to publish on between the first one and the end of the chain, and that will dually start doing the processing from that point onwards in that scheduler context. So it's really easy to change where the things run. Now, it's also easy to get carried away with this, and it's usually not a good idea to get too carried away because you can have a lot of overhead introduced by moving things between thread contexts. But a very common way to do things, especially in Android, which uses RxJava, which is another variant of reactive semantics like Project Reactor, they'll often do something where you'll say, subscribe on, and then have something run in the background to do long-running computations like do HTTP call to a server or rebalance a database B tree or whatnot. And then they'll say publish on, and they'll take the results and publish on the main user interface thread in Android, because that's where you have to do any user interface related stuff. And so it's really a nice idiom that you see a lot in Android, and it's very convenient. You don't have to do a lot of tricky things to make that work. Again, beware of publishing on too many different threads within a chain, because you end up spending all your time moving stuff between contexts, which is slow. Why is moving stuff between contexts slow? Well, that's a good question. And so the reason I'm advising against changing schedulers and thread contexts is because there's a cost associated with that, and the cost is typically in terms of context switching, synchronization, data movement, and probably memory management as well, which also then gets into the issue of synchronization. So context switching, it's very syntactically easy to write code like this, but if you're not careful under the hood, moving things between threads requires switching from one thread context to another, and that has overhead, unless you're using virtual threads. But if you're not using virtual threads, there's actually overhead of moving things. And there's also synchronization overhead, because you have to move stuff from one queue to another, so that requires synchronization. You often end up with messing up caches in the processor core, because you're moving the content of the data and or computations between caches, which invalidates caches. And then you typically have to allocate a lot of memory, or the virtual machine or the implementation of this allocates memory. So if you're not careful, you can spend a lot of time thinking you're getting a win when in fact you're not getting a win at all. You're actually slowing things down, like the picture of the melting clocks illustrates here. The interactions between publish on and subscribe on are somewhat convoluted, and you can read this article to learn more about that. I try to use them when appropriate, but I try not to get carried away, and it is very subtle in some cases. RxJava has an observe on operator that works exactly the same way that the publish on operator works in RxJava. I have no earthly idea why they came up with different names for that, but they did, so go figure. And then the final thing we're going to talk about here are the scheduler operators used by the Flux class. And we're going to start with the new parallel operator. And what this does is it hosts a fixed size pool of single-threaded executor service-based workers. That's just the implementation details. And the first parameter gives a name for the scheduler, and the second one indicates how many threads you want to have in that pool. And it returns a new scheduler that's suitable for parallel computations. And Interestingly enough, this is really intended for compute-bound computations. If you end up doing blocking calls, a good example of a blocking call would be a call that was doing something related to I/O. That will be rejected. So you can't do blocking calls with the new parallel operator. There's a thing to remember that new parallel has limitations, and one of the limitations is that you can only use it for non-blocking calls. So you can use the new parallel factory method to create a custom parallel scheduler. Here's an example. We're going to generate a range of values from 1 to S max iterations. We're going to convert those to unsigned longs. We're going to have all this computation run in the background in the publisher thread, which is a new parallel publisher. Notice these are all computation-bound operations. And that will then run the whole thing in that publisher thread. Something I'll note here, and we'll come back to talk about later, you have to make sure you dispose of the publisher or you'll leak resources. And we'll talk about how to do that with the doFinally method, which is kind of like a destructor for a Flux stream. A thread allocated by the parallel scheduler is not implemented via a daemon thread. So therefore, you have to shut it down explicitly. And that's why we have this publisher dispose in here. Very easy mistake to make. And if you don't dispose of it, then your program will hang and will not exit. RxJava does not have an equivalent method. It has a bunch of other methods, but it doesn't have that particular one. And you can use the from method on the RxJava scheduler in conjunction with Java's executor framework to spawn custom thread pools if you so desire. And here are some examples of the kinds of things you can make with this particular approach. You can make a fixed-sized executor, you can make a variable-sized executor, or you can make a work-stealing executor. We're not going to spend a lot of time talking about that. That's just for broader understanding. So that's the end of the overview in our discussion on key concurrency and scheduler operations in the Flux class. And as you can see, we'll talk about other operators later in other parts of this course.